Okay, so yeah, this is our course, Stats 102A, Intro to Computational Statistics with R. This is it. I just last night I posted the syllabus. I'm sorry for taking so long to get it finalized and posted. And let's see. Let me log in. Sorry. Do you guys use Duo?
Yeah.
Yeah? No? Okay. Well, I'm a big fan of two-factor authentication. You guys are not. I mean, it's like I wrote up some instructions, for keeping some backup codes that you can follow here. Okay, so I wrote up some instructions here to make some backup codes because right now you need your phone, right? And you need to have it. And if you leave your phone somewhere, then you're like stuck. But there is a way to have backup codes that you can like store in your email or something. Just in case you need to log in when you don't have access to your phone. So I do recommend doing that. It's kind of like, but as a word of warning, it's kind of like keeping a key to your house underneath the doormat. So you don't want to make it like too obvious that you have backup code sitting around. So, you know, like if you follow the instructions, I tell you what you should do. But anyway, you know, having two-factor authentication, I think, is a good idea. So, but anyway, we'll open up this. Here's the syllabus. We'll take a look at that, and then we'll get started. Before we do that, let's see. Can you guys, are you guys able to read the screen? Okay, there, more or less. Okay. Well. My name is Miles Chen, and I will be your instructor for the quarter. I am excited. I love statistics to begin with, and I especially love, I don't know, this computer programming stuff, the computational aspect of statistics. And this is kind of, you know, in the last 10, 20 years or so, the field of statistics has been moving greatly into this direction of computation and using computer-based methods for solving statistical problems. Prior to that, and still in use, are the traditional methods that involve ANOVA and things like that. But we are shifting kind of from a time when data was very expensive to kind of a different paradigm where now we have too much data. There are still fields where data is very expensive, and what I mean by that is if you're going to do an experiment to test if a new drug is working, you need to get volunteers and participants, and you might, if you're lucky, have like 50 subjects to study, and you give them the drug, the experimental drug, and you get some other group to do the placebo and things like that. You have a total of 50 data points, okay? You want to design your study in such a way to get the most amount of information out of those 50 data points, okay? Or, you know, something else, some other type of thing, you know, if you're like crashing cars to see how safe they are, every single observation is really, really expensive. It's the cost of a brand new car. So, statistics in the early days developed during a time where observations were very expensive and things like that. Today, in kind of the information age, we still have that aspect. You still have people doing medical tests. You still have people doing these controlled experiments where each observation is expensive, but we're also have another source of data, and that's everything electronic, everything on the internet, everything with your phone, whatever. We just have mountains and mountains and mountains of data. and we're trying to make sense of it, okay? And when you're dealing with these mountains of data, and we like to call this big data, whatever that's supposed to mean, it is, you need computer-based computational methods to handle that. There's no way you can kind of go through it manually. And so this class serves as kind of our introduction to that. We don't get to go really, really deep. The first half, thematically, the course itself is split into two parts. The first half will focus a lot on R programming, a lot on kind of learning some of the packages and tools that we would use. And then the second half starts to get into a little bit of the computational methods. And so we'll look at things like root finding and unidimensional optimization, so optimizing functions of one variable. We'll look at some randomization tests and Bootstrap, and that's what we'll cover this quarter. And then in future quarters, when you take classes like 102B and 102C, you'll cover more aspects. Okay. My office hours are going to be Mondays at 2 and Fridays at 11. So right after this class, I'll have office hours, and then on Fridays before lunch, I'll have office hours. And if those times don't work, send me an email. We'll try to work something out. I'm generally on campus only Mondays, Wednesdays, and Fridays. So if you ask something on Tuesday or Thursday, I will most likely say I'm not going to be around. Okay. Everything's posted online. This is going to be the dates of our midterm and final. I just have the midterm. I'm waiting for the registrar to tell me when the final exam is scheduled. So I don't have any control over when the final exam is scheduled. If it's Friday of finals week at 3 p.m., that's like the worst, but sometimes it happens. You know, there's a 1 in 15 chance that it does. So I don't know. We'll see. Okay. It's just going to be whenever it's scheduled. You know, I would love for it to be scheduled, you know, Monday at 11 a.m. and then we'll be done. Well, I would be done, right? I don't know about you guys, but that's best case scenario. But okay, you guys have all taken Stats 20? Anybody not take Stats 20? Okay, good. So I'm assuming we all know how to do stuff. Okay, and then books. I was able to find everything I need in books that are freely available. I shouldn't say free. Your tuition and UCLA is paying for these library subscriptions. But yeah, as long as you are connected to the UCLA network, you click any of these links, these will be available to you for free, right? You guys know about CRC NetBase and Safari Books Online, Springer Link? No? Okay, well, let me tell you. So because you guys are students here at UCLA, and UCLA is a big school and has money, we have subscriptions to these major libraries. One of them is Safari Books Online, and this is like so amazing. If you just go to proquest.safaribooksonline, this is kind of our academic subscription thing, you have basically access to the entire O'Reilly catalog of programming books. So you want to learn machine learning with scikit-learn and TensorFlow, this book is available for you to read. You just click start reading and it's all in here, okay? This is a great resource. You need to be connected to the internet to get it. You can't download these books. But other places like CRC NetBase, I should have clicked, I guess they renamed it to Taylor and Francis. You can download the textbook as a PDF and get the book there, right? So I've tried to do that. With the 102B class, I couldn't find textbooks that suited my needs that were completely free, but for this class I did. So, so anyway, the entire textbook here for free. Of course, you know, if you are, if you like print books and you want to spend the money, you can spend the money and buy the print book. I'm not going to stop you. But that's what we have there, okay? So everybody's got the textbook, and so they're listed in the syllabus, so like later on in like week 7 or 10 or whatever, and I'm saying like, look at the Ziegler textbook. Don't ask me where it is, it's in your syllabus, okay? Let's see. Grading, we've got homework, we've got a midterm, we got a final, and then I'll occasionally take attendance, and then I'll have a Piazza forum, and I'll give points for participation there. Occasionally I might have an in-class poll, and that will count towards your attendance grade also, all right? Homework assignments, there's 6 of them. They'll be worth 7% each. None of them are dropped. They're all going to be R Markdown files, and you'll I'll have the questions there, you'll fill out your answers, and you'll submit them, okay? This is, I want to say this, I'm going to say this now, because students come during office hours and ask for regrades on their homeworks, but usually, like, 80% of the time, it's something like that could have been avoided, okay? So a lot of times I'll ask you to write some code to perform a certain task, right? So I might say, produce a vector of the first 10 numbers in the Fibonacci sequence, or something simple like that, right? And you might write the code, and this code is technically correct, but you don't print out your result, okay? We can't give you points if we don't see the result. And so, you know, you'll lose points. You're not going to get credit for the submission, even though technically the code is correct. And the reason for this is because, you know, there's 160 of you in the class. I've got 2 readers. They can only spend, you know, at most 5 to 10 minutes on your homework assignment. They don't have the luxury of copying and pasting every single line of your code to run it and see if the results are correct. So it's your responsibility to make sure the results print and show and appear. And, you know, if it says produce a vector of this and you click print, the only difference between the good submission and bad submission here is this one said print out the result, X. And now we can see the result, and now we can score it appropriately. When you do your assignment, you know, you're going to render your HTML file and you're going to submit your HTML file. Make sure you take the time to read through your output and that everything that's supposed to be there is correct, okay? So please do this, okay? I will send out a link for Piazza. It's going to be an online forum, and you can post questions and answer each other's questions there. The goal is to get you guys to answer each other's questions and help each other out that way. I will occasionally chime in with answers, but you know, in the past I used to be the kind of the primary answer giver. I want to try to shift that responsibility to you guys, and only if like the discussion's like going bad and it's very clear that you guys are wrong, then I'll chime in and say like, wait, hold up, that's not correct. But that's what we'll do, okay? Here's the late policy for homework. Most of the time I'll make homeworks due around 6 p.m. And the goal is that you finish it and then you can have dinner and enjoy the rest of your day. Rather than making it due at midnight and you skip dinner or something, which is not a good thing. And there's going to be a 10-minute grace period, so you can turn it in up to 6:10:59. No penalty. We're going off of CCLE's clock, okay? And don't tell me your clock was different from CCLE. And then after that, every hour is 5 points off, okay? So, you know, every hour after that, you'll lose 5 points. I have the points stop at midnight because I want you guys to sleep. Sleep is important. So make sure you sleep, okay? So the points stop at midnight to 8 a.m. Because you're supposed to be sleeping during that time. I don't know. Do we have to read through the entire syllabus? You guys can read, right? Okay, so just read all of this. Okay. Treat everybody with respect, and but if you find yourself a victim or struggling with mental health issues, that does happen. The university does have resources to help you guys, and so those are all listed in the syllabus. There's the Counseling Center and then the Center for Sexual Harassment and Sexual Violence. I hope nobody is a victim or suffers mental health issues, but I know the reality is that life can be ugly and messy, and so there are people and resources at the university because ultimately we do want you guys to succeed and do well and flourish and enjoy your time here at UCLA. And I want you to enjoy this course also. So so anyway, please take the time to read through the syllabus. And I don't know, before we get started, are there any questions? Yes?
When will we know when the final exam will be?
When the registrar posts that, it's usually around 4th week, something around there, usually. I'll check with the department administration and see if they can get answers faster, but the registrar often tries to figure this out. So, yes?
There's a final conflict time with it, or will we get...
Yeah, I mean, we'll work something out, okay? If you have 2 finals on the same day, I'm going to say, sorry, that happens, that sucks. But if you have 3 finals on the same day, I'd be willing to consider that. And if you have 2 finals at the exact same time slot, we can't work that out. But 2 finals on the same day, it's not fun, but it's survivable. I'm sure many of you have endured that already. So, okay. Any other questions? All right, then we'll begin. Okay, so this is the class, and that's me. Okay, I think you guys know how to get to 8105. It's right across from the elevator, right next to Glenda and Lori's office. So you guys laughed. All right, my commitment to you. You are the paying customer. This is true. And I want you guys to be completely satisfied with the course and the teaching I provide to you. I hope when you guys submit your reviews that they're very good reviews. And I see it as my job to teach you guys and help you learn skills and methods for data analysis. Okay. And I hope you like the class, okay? These are my expectations from you. I expect you guys to let me know of any problems that you guys are experiencing, not to just be passive-aggressive about it. And please put in a good faith effort. Some of the homework assignments will be hard, okay? This is a very programming-heavy class, and if you don't like programming, this is not the class you want to be taking. And if you don't like programming, and I would suggest, this is always risky, that statistics is probably not the best major for you if you don't enjoy programming. Now, if you are not, quote, good at programming, that's okay. Not good can be overcome with hard work, right? Because with practice, you'll get better, right? Even if you are like terrible now, if you practice and do a little bit, you'll get better. And that's everything, okay? So please put forth a good faith effort. It will be tempting at times to look at someone else's solution for the homework, okay? Resist that. Do your best to solve it yourself. I think a lot of learning happens when you struggle through a problem, and you don't learn as much when you copy, okay? Because there's no thinking involved in copying. Well, especially if you copy and paste. If you type each character out one by one, there is a little bit of learning there, okay? There is. Have you heard of like learn the hard way? Like learn Python the hard way and things like that? Well, he has you learn by just copying code character by character. And it is effective, that is true. Okay, well anyway. I did, under week 1, I posted, homework 1 is up, by the way. I posted a TED Talk on having a growth mindset. And, you know, lemonade, what is that? Anyway, while it's week 1 and you've got all this extra time, watch this TED Talk on having a growth mindset. And then during week 7, when things are falling apart, watch it again and encourage yourself. Yes, maybe I'll post it again in week 7. Basically, the point of the growth mindset is if you approach life, rather than saying I'm good or bad at something, if you say I'm going to learn something and I have to keep working harder at it, you'll succeed. It's, the example he uses is this chess master who did really great, and then he decided to learn martial arts and said I'm going to work really hard, and then he became really good at martial arts. So anyway, do that. Okay. Oh, what is this class about? It's a statistics class. All right, and so in general, I always, and I say this in my Stats 10 class, and I say this now, is that statistics is to help us gain a better understanding of the world. And the subject of statistics allows us to take data and draw something meaningful from it. And we should always be asking, what does the data that we have tell me about the world? And oftentimes when you have a big data set, the first thing you want to do is do a little bit of exploratory data analysis, which just means start summarizing it, right? So rather than having to look at 500 entries, which is difficult for a brain to process, just summarize it down to like 1 or 2, 5 numbers, okay? Maybe split it up into groups and summarize the groups by 1 or a few numbers, things like that. You know, that's the descriptive part. And then we start going into the inference part, which is I'm observing something here. Maybe this group has a mean of 10 and the other group has a mean of 12. The difference of 2 points between the 2 groups, could that just be randomness? Or does it indicate that the 2 groups are actually different? And that's kind of probably what you covered in Stats 10. And you covered hypothesis testing. And so, you know, you'd say, maybe you have a set of data and you say, the data that I have has a mean of 11.3, and my null hypothesis says that the population has a mean of 10. Well, is 11.3 different, significantly different from 10? Is that statistically significant word? And you used kind of the rules of probability. And you guys all took 100A by now, I think. And so you'd say, if the null hypothesis were true, if the population truly did have a mean of 10, what's the probability that a random sample ends up with a mean of 11.3? And maybe it turns out it's very unlikely for randomness to produce a mean of 11.3, okay? And if that's the case, then we would say we have evidence that the mean, that the population from which this random sample was drawn, we have evidence that that population does not have a mean of 10. I'm hoping this feels familiar to you guys, right? From Stats 10. Okay. And all of that stuff that you did in Stats 10 is probably based on the central limit theorem, right? The central limit theorem says that you draw random samples out of the population and the means follow a normal distribution, or you do this with a proportion and it looks like the normal distribution. And you probably Did you do the central limit theorem in 100A? If not, it'll definitely be in 100B. You probably have to support all of that, and so that comes from kind of this analytic methodology where we have this underlying math to back up the methods that we've done, right? In Stats 10, you have the central limit theorem, and there were conditions that had to be true in order for the central limit theorem to be used. And in Stats 10, we never proved it. In 100A and 100B, you probably had to prove it. And we say, ta-da, that's how it works. In this class, we're going to do computational statistics. Computational statistics, does my microphone like gain randomly? Allows us to avoid having to do complicated math, okay? That's not why we do it, but, well, sometimes it is. We don't rely on the central limit theorem. We just rely on randomness, and we say the computer can do randomness for us, and we apply these methods to answer our questions, okay? Computational statistics is not, quote, doing statistics with a computer. So like if you do 101A, 101A is on regression, and you're still going to use a computer. You're going to use R to do all of your data analysis. But that doesn't count as computational statistics. It's, the computational here is using these computer-intensive methods like simulation and resampling to answer our statistical questions. Okay, so I think I've mentioned this already. Thematically, we've got kind of two parts to the course. This is by design. First, we're going to learn the tools of computational statistics. So we're going to learn R and some packages in R. And then we will learn some of the methods, introductory methods for computational statistics. Okay, these are the tools. This is some we'll cover. And you guys are already familiar with R Markdown, correct? Anybody not familiar with R Markdown? Okay, then I'm going to skip all of this. Okay, and then there's a newer cheat sheet. Well, 2016. It's a good one. Okay, so we'll do that. You render it. So this is just how you're going to do all of your homework. You download the template, fill in your answers, render it, submit the HTML. This presentation is also done in R Markdown. And usually I post the RMD files for the lectures online, and so you can download those, render them on your computer, and follow along here. And then you can add notes and things like that if you want. Okay, so then we'll get started in terms of topics within R, and the first thing is going to be data structures in R. Some of this will feel like review, but also I think we're going to dig deeper than what you did in Stats 20. So I'm approaching this with an assumption that you guys all did decently well in Stats 20, and we'll just kind of revisit some of these things in a little bit more depth. Okay. So we've got you're probably familiar with vectors and matrices, lists and data frames, and we can kind of organize these into this idea of homogeneous or heterogeneous data types, okay? Homogeneous meaning everything, all of the values in that data structure are of the same type. So when you have a vector, all the values in the vector have to be the same type. They all either have to be all characters, or they all have to be Boolean, logical values, or they have to be numeric values, and we split the numerics into integers and doubles, and that's what we have. And if it's one-dimensional, just a vector of values, we call that the atomic vector. And then if it's a rectangle, then it becomes a matrix. So a matrix is two-dimensional, but all of the same data type. And then you could have multi-dimensional, n-dimensional things, and then we call these things arrays. If we have different data types, we can store different data types in the same structure, and that way we have a list, and then we also have a data frame. Okay? We don't have an n-dimensional thing for different data types, and that's fine. Okay, the different types, the four major types, or most common types, are logical, double, integer, and character. And we just ask R using type of to kind of close this out. Okay, and let's see. Oh, we're cut off on the edge. Okay, and then so you can say 4, and you can say type of 4, and R says that is type double. Okay, and if I say type of, and I put in quotes 4, then this is going to be, it's not the number 4, but it's a character string, and so it's going to say it's character, right? So anytime you have words like hello, that's going to be type character. Type double is going to kind of be your numeric type. If you do the values 1 through 4, however, this is integer type, okay? So you don't have any decimals. Double means you can have decimals. Integers don't have decimals. But this is different. So 1 through 4 is different from 1, 2, 3, 4. Although they look the same, if I ask what is the type of this, this is type double. Okay. Well, anyway, so and then logical is you kind of your true or false. Those are your logical types. You have complex and raw. We don't really worry about these complex if you're dealing with imaginary numbers, and raw if you're looking at like assembly memory codes and things. Okay. So we got atomic vectors. Atomic vectors are homogeneous. That means everything in the vector must be of the same type. So we'll just take a look at these. We start off with the logical vector. Logical vector will contain true or false. I recommend typing out the word true or false in all caps. These are reserved by R. So true is true. R has a shortcut where if you just type in T or if you type in F, you're going to get also true or false. However, this is the thing. You can type in T and store in a value to it, okay? And if you say T is equal to 0, and then later on you say if T is true, print hi, this is not going to return anything because it's looking at 0 equals to true. So that's not a good idea. Meanwhile, you can't overwrite the value true. It's going to say you can't do that, right? So so it's not a good idea to make variables with capital T or F, and it's not a good idea to just use that either. So anyway, type of true, logical, you create a vector of these things and you ask the type of that, it's also logical. Okay. You put in, as soon as you start using quotes, now you have character data. Okay, so a single vector of length 1, character data, vector of length 3, still character type, right? Double, as soon as you have decimals, it's going to be type double. The default numeric type is type double, so even though you say 4, or you create the vector 1, 2, 3, it's going to go in as double. And then integer, if you want to type out an integer, you can use the capital letter L, and that makes the number an integer. Okay, so 1L is integer, and if you use the colon, it creates integers. Right? So, but if you just do this, you can't really tell that this is integer. It looks like the only way you can do this is you say like, okay, A is going to be 4L, and you say type of A, it's integer, right? And if you have B is 4, and you say type of B, it's type double. And then let's do D is 4L plus 3L, okay? So D is 7, what is this? That's going to be integer, but whereas E will be 4L plus 3, what will this be? Double. So if you add an integer with a double, it coerces the integer to type double and mixes the two. Okay. Anyway, you use the function C to combine things. Okay, and so you've got C is 1, 2, 3, and you've got 1, 2, 3 together. You've got hello, comma, world, and you've got that. And then if you combine a vector in with another vector, it just flattens it out. Okay, you can't have hierarchies using C for atomic vectors. All right, so type of will tell you what kind of type it is, but you can also have it return true or false, and you can say, you know, is logical, character, double, or integer. And you also have is numeric. Is numeric will return true if it's integer or double. All right, what do we got? Is integer 3? No, right? It's a double. Is integer 3 colon 6? True. Is numeric 3 colon 6? True. Is double 3 colon 6? False. Right? Okay. False, true, true, false. Good job. Is atomic will return true if it's an atomic vector. Is vector will return true if it's an atomic vector or a list. Okay, so basically if you give it a matrix, it's going to be false. What will be, is atomic, is this true or false for a matrix? It's true for a matrix, okay? So if I say G is a matrix 1 through 4, n row is equal to 2, and I got G, we got this, is atomic G, this is true because technically a matrix is an atomic vector with just dimensions attached to it. So is atomic is true for any atomic vector. We have, what do I have here? Where's my environment? We just have all of these things. Is atomic A, yes. Is vector, is matrix G a vector? That's going to be false. We also have coercion in R. R is a dynamically typed language, meaning it doesn't complain about doing operations with different types of variables. So if you say, I want to combine the double value 1 with the character value hello, R will say, okay, I did my best. And it makes 1 a character and it combines it with hello, right? Because the output of C, when you create an atomic vector, everything has to be the same type. So if you combine a logical value, false, with an integer, it's going to coerce these things to type integer. Here we have a double value and a integer value, and it coerces them to both double type. Okay. And the way it does this is it just looks at the least restrictive form of what you're giving it, and it coerces everything to that least restrictive form. So we've got logical is most restrictive, then and character is the least restrictive. And so here I've got L for logical, I for integer, D for double, and CH for character. And if I use C for all of these things, if I do logical, integer, and double, it's going to say, okay, the least restrictive type is type double, and it coerces all the logical values and the integer values to type double, and we get this 1, 0, 1. Trues are 1s and falses are 0s, and it outputs that. If I combine the logical, double, and character, it's going to say, well, character type is the least restrictive, and it goes directly from logical to character. So the logicals remain as true, false, true, and everything gets turned into characters. Okay? If I did this first and then combined the output of this with here, then the logicals got converted to type double, 1, 0, 1 first, and then would get turned into characters with quotes, 1s, 0, 1. Okay? So it just looks at the least restrictive form and then it goes straight to that. You can manually coerce things yourself. You don't have to do a combine operation. You can just say, I want to take this and make it numeric. And then other functions will do this also, like sum. Sum is expecting numeric input, and if you give it a logical vector, it's going to coerce all of your logical values to zeros and ones and add them up. So here I've got false, false, true. As a numeric, that's going to be 0, 0, 1. If I add those up, the sum, I get the sum of 1. This is also very handy. If you just do mean of a logical vector, it's going to give you the proportion that's true, right? So here I've got 3 values, 0, 0, 1, 1, if we're looking at these false, false, and true. And if I do the mean of that, the mean of 0, 0, and 1 is 0.333. So the proportion that's true of our original vector is just the mean of x. Okay. No need to do coercions here. Is that all good? Okay. Most of our mathematical functions will try to coerce anything into some kind of numeric vector. And if we have logical operations, it will try to coerce them into logical. So when you coerce a number into logical, everything gets coerced to true except for 0. So if I do as.logical 1, that's going to be true. That makes sense. But if I do 10, that's also true. And if I do negative 10, that's also true. The only thing that doesn't is 0. Okay? Positive or negative 0 both get coerced to false. Okay? Character just takes whatever it is and does that. And as.integer just truncates. Okay? So as.integer 3.1 is 3, and 3.999 is also 3. Okay? It's not a rounding, it's a truncation. Just takes the integer component and truncates. All right, so here we go, as.double. As.double, if you give it a characters thing, it will try to convert it to a number as best as it can. So there you go, but if it can't, it's gonna say, I can't do it, NA. Right? R has, among different programming languages, R is a favorite among statisticians because of this feature of NA, okay? It explicitly has a missing value type, whereas many other languages don't have something to express a missing value built in, okay? If you ask what is the type of NA, the type of NA is logical, okay? And so if I say, here I've got NA and I've got this, and I say type of NA, it's logical. And then if I do NA plus 1, it's also NA, right? And let's say we're going to store A as NA plus 1. A is NA. But then if I say type of A, whoops, lowercase a, it's type double, okay? So we actually have NA types of the default NA is type logical, but we also have NA for basically numeric values, integer values, type double, they call it real for whatever reason, and character values. We have NAs just so that you can have, right, if I say D is going to be a vector with the values 1, 2, 3, and NA, D is a logical is a atomic vector, meaning everything in this vector has to be of the same type, right? So 1, 2, and 3, these are going to be type double. That's the default numeric type, and we also need a missing value, an NA, that's also type double. So if I subset this to D bracket 4, this thing is going to be type double, okay? Because the rule is that atomic vector has to have all of the same type, and so even though it appears NA in all of these things, one is NA for logical, one is NA for double, one's NA for character, okay? And that's why the default NA is type logical, because that's the most restrictive form and it can get coerced into anything else if need be. We have other special values. Just got to make sure we're on time here. These things like not a number, infinity, and negative infinity, these are type double, okay? These are things that are represented in the computer for values that are too big to be stored in memory, or things that are not numbers. So if you say, pi divided by 0, that's going to be infinity. INF is infinity, and if you say type of infinity, it's going to be type double. Okay, infinity and NaN, not a number, is also type double. Okay, and you get something like, 0 over 0 will return not a number. You do an illegal operation. But yeah, and you don't have to worry about this exact slide here. You get weird things, right? So we'll skip this quiz. You can look over the quiz on your own time. All right, last two slides, I think we'll do this. Okay, we have a few operations like addition and multiplication go element-wise. Okay, so if you have the vector 1 colon 4 and the vector 2 colon 5 and you add them together, it's going to do 1 plus 2, 2 plus 3, 3 plus 4, and 4 plus 5, and it gives you that. So it just kind of matches them up element-wise. Same thing with the multiplication, it does that. Hang on, I know we're like right there. Just wait 1 second. Recycling elements, okay? If you have vectors that are of different length, R will recycle them, okay? So here I've got the vector 1, 2, 3, 4, and I've got the vector 2, 3. And if I say multiply these together, it's going to be 1 times 2, 2 times 3, and then it goes 3 times 2. It's run out of the first vector, 2, 3, and it recycles back and it goes to 2, 3. And so it does 3 times 2 and 4 times 3, and you'll get this result. Whereas over here, I have the same, something similar, except the shorter vector is not, the longer one's not a multiple of the shorter vector. So I've got 4 elements over here and 3 elements over here. So I've got 1, 2, 3, 4, and then 2, 3, 4, and then it recycles back around to 2. And it does it. But then it also complains. It says, here's a warning. I'm not sure if this is the thing you wanted me to do, because it's really weird that I went 2, 3, 4, and then recycled back to 2, and then I stopped. So R says, that was kind of weird. Are you sure you wanted to do that? And it spits back a warning, okay? A warning means it'll do it, and it's not going to give you an error, but it just says, I'm not sure if this is the result you wanted. Okay, well, we'll end here. Thanks for sticking around, and looking forward to a great quarter with you guys.